let's consider ang mga code provisions natin. Okay, so let's regard as a cross-link design something like that. So let's proceed sa ating first part. So for our first method, which is the 4 methods natin, or 4 procedures. Natandaan niyo. 4 procedures for designing roads. Anong first gamit? That is the directional procedure. Okay, we're in for our directional procedure. Ang aton niya na principle is, ang aton nga wind effect is, say, kami sa uniform, yung wind pressure at all sides or in 4 directions, which is your windward, side walls, tab, and yung leeward wall. Okay, so for our directional procedure, we will have specific buildings. So first, ang aton na MWFRS. Okay, or aton na main 3 to 4 system. Okay, we're in, we will have 2 types of buildings. We have some rigid, flexible buildings. So this is at all heights, we have 2 types. Okay, so we will use section 207B. Okay, sa inyo na CP, sa hindi pull out, sa inyo na CP. 807B.4.1. Okay, sino may first printing na iliwan? First. Chapter 2 lang ha. Sino second printing? Chapter damon. 807B.4.1. Okay, so this is for MWFRS. Okay, so we will have 2 types. Okay, under 207B.4.1. Hindi ko siya ma-display sa screen natin wala pa yung CP. Okay, ano na sa page 2-42 for second printing. For first printing, ano naman page? 207B.4.1. Okay, for second printing, this is page 2-42. Okay, ano na? 207B.4. Okay, so we will use MWFRS for buildings in all heights. Okay, ma-notice ninyo, we will have 4 types, 5 types of structures. Okay, ano nakasulat sa 207B.4.1? Oh, Mr. Epan. Enclosed and partially enclosed rigid buildings. Okay, ang 207B.4.2. Oh, Mr. Siniting. Ano makita ka?
Sir?
Yes.
Enclosed and partially enclosed flexible buildings.
Flexible buildings. Out of third. Wala point 3, no?
Meron, sir? Open buildings with monoslope pitch or trough free roofs.
So this time, this is open buildings. Okay, anong 4 ang 4 at 5? Roof overhangs cut parapets. Okay. So we will have 2 classifications. Okay, so we will have enclosure classification. Okay, so for our building of all heights, okay, so may 2 types of buildings, which is your MWFRS. Okay, so that is under sa 1 kag 2, no? Kag 3. So 207B.4.1, .2 kag .3, that is for buildings. Then, may harap sa roof overhangs. Okay, what do you think ang mga roof overhangs? Ano sila? Mga bulada sa ato. Lain ang effects ng hangin sa bulada. Ang projection lang ang labaw nyo nga ito. Lain ang hangin niya. Ay perception siya. Okay? And lastly, inyo nga parapets. Okay. Ano yung mga parapets? Sila nagsaka roof deck sa Ayala. Ano masaka sa roof deck sa Ayala? windows, no, for our RCDN, okay, so we'll determine ato nga design windows, maasa ato nga main reinforced existing system or ang ato nga building frame or commonly known ang ato nga structural bed. Okay, but under sa ato nga to 17.4, we will have 3 types. Okay, so first type is that is for enclosed and partially enclosed. Okay, the second naton based on rigidity. Okay, so we will have rigid buildings and flexible. Okay, so first naton is will be applicable only to partially enclosed and enclosed na rigid. Okay, take note on partially enclosed and enclosed rigid buildings. Okay, so this is important, no? We must identify if what type of building ang ato na i-compute, no, for minimum design loads, especially windows. Kaya nainay ang ilang procedure when it comes to their classification of the building. So first, we must learn how to identify if anong iyang enclosure classification. So we will have 3 types, which is enclosed, partially enclosed, and open. And let's determine if ang building is rigid or flexible. So I know most of you are familiar on how to classify rigid and flexible buildings, but I think sa inyo nga sariwan, wala na na-discuss, no, regarding enclosure classification. So una ako nagawa. How can we classify if the building is enclosed, partially enclosed, or open? Then we will identify if the building is rigid or flexible. Okay, so doon na. Enclosure classification. Ikaw, sa likod. Ilang baklas na mo TV sa isa. Okay. So according sa code ko, no, okay, actually inyong second printing wala sa mga komentary. Diba wala komentary? First printing ang may komentary. Okay, accordingly, the code requires that a determination be made, no, of the amount of openings in the envelope. So what do we mean by envelope sa ating na building? What do we mean by building envelope? Ating na building envelope is the exterior part sa ating na building, which is embraces sa ating malagayan roads, especially ating mga windows. And as per commentary, no, okay, when we refer openings, so last time we introduced siya ng kamay regarding openings. Openings are specifically defined in this version of the code as apertures or holes in the building envelope. So meaning, tanan na part sa inyong building envelope na may buhok, okay, which allow air to flow through the building envelope and which are designed as open during design winds. Okay, so what do we mean by that statement? Designed as open during design winds. O let's say, kung i-close yung window during design winds, may hangin pala. May ara. Siyempre lang magpakita sa hangin na may bintana. Pala, siyempre huyog doon sa hangin. May mala. If na-allow siya air to flow through the building inside. Okay? So galing, ang question to that, ang ato sa mga windows, may glazing. Okay? So ang ato na glass sa mga window, these are called glazings. Regardless, no, if what type of glass ang gamit. So may akata sa mga ordinary glass, may kakain glass, may tempered glass. Okay? So these are all glazings. And as per commentary, no, okay, we consider katanan ng glazings during strong winds, meaning during strong typhoons. Okay, nga ang glazings pwede siya mabuka sa mga debris. Thus, allowing ang ato na external wind pressure or external wind natin na mag-flow inside the building. So regardless kung saan siya kabakod ng glass ninyo, we will consider this, okay, as an opening. Bukas man or sirado ang inyong bintana. Okay, hindi ako lang naman study difference. Paano malambal na open in the building? May open, sir. Ang dami na. Okay, ang building is classified, no? Ang ating windows as openings, regardless if open siya or closed, regardless if what type of glass ang gamit. Okay, these are all openings. Okay, so let's recall ang aton na internal wind pressure. Okay, ilang kabilog ang aton mag-radiating wind direction? Ilang kabilog? We will have two types of wind direction. Maguyog siya, either parallel to ledge or perpendicular to ledge. So we will consider, no, ang atong mga openings first, kung sa diin go yung hangin. Okay. So if this is our prevailing wind direction, ang hangin, dali siya mauna sunod. Okay. Okay. And eventually, no, ang atong hangin is magwa siya. Okay. Either sa side walls, either sa ating leeward wall. So, muna itong basis for our enclosure classification. Okay? So, we mentioned earlier, isa pakitangin na ako, no? Ang bal niya, this version of the code has 4 terms applicable to enclosure. Okay, so we will have windborne degrees regions, glazing, impact resistant glazing, and impact resistant. Okay, so ang consideration is, we will consider all degrees sa palibot natin during strong winds will have an impact sa glazing na pwede siya magbuka. Regardless, if ang ating window is high tempered glass, no, or high annealed glass, pwede siya maging source sa atong internal wind pressure na siya maglabay. What if, sir, ang among na building is composed of curtain walls? Sino pamilya sa curtain walls? Kita ng building ang puro glass sa dami. That is a curtain wall. Don't worry, sa inyong building, hindi mo makita ang building sa Manila. May mga curtain wall. Okay, so usually framing mo na siya, wala siya sa masonry wall. Okay, usually tipid ng building, yung mga framing, di ba, yung beam, ay mga beam, mga column. Tapos between columns, kung saan sa imo na masonry wall, then imo nga window. But for our curtain wall, okay, there siya ka-frame, dito ma-act as curtain ang inyo nga window. Do cortina lang siya nagitulog sa imo nga building frame. So katapin sa imo nga beam, pero wala isang wall. That's why ang ilang nga window is full height. Okay? Beam to floor sa imo for level. Okay? So lipat ha, all windows, we will consider them as opening. Okay. So for our 3 types of building enclosure classification, which is open, partially enclosed, and enclosed. Okay. So you can see this section 202. Okay. So we can say that the building is open, okay, having each wall at least 80% open. So first natin na condition. Okay. Kaya first building have each wall hindi lang isa ka wall. Okay. Each wall at least 80% open. And this condition is expressed for each wall by the equation of AO is greater than or equal to 0.8 AG. Merong AO ka, AG.
Next page din. Total area of openings in a wall that receives positive external pressure.
At section 2 under sa inyong mga definition of terms. So sa inyong annotation sa inyo.
Ano sa ho? Scenario? Laing yung page. First.
So let's say this would be our prevailing direction. Okay. So ano siyang direction? This is parallel to ridge. Okay, so ang atong na AO is a total area of openings in a wall that receives positive external pressure. So if nagigawit ang hangin, diin na siya nga wall. Hindi na consider na to. Ang aton nga windward wall. Okay. So if this would be our openings, tanan nga sum sa ilang openings. Nag-receive. Kasi may windows ka din. Okay. Sum sa ilang areas. Kaya anong AG? Sa inyo na sige.
Gross area of the wall in which AO is identified.
Okay. Gross area. Gross area
Of the wall in which AO is identified.
which AO is identified. So for short, we can classify our building as open based sa atong na windward wall. Okay? So this would be our gross area. Okay? So AG is the gross area. Okay? Section 2, AG is the gross area of that wall in which AO is identified. And ang atong na AO is the area of this openings. Ito. Okay. So as long ang atong na openings is 80% of this gross area, we can consider our building as open. Okay. Ako naman iya only condition. Okay, what if, sir, dali na kuyog ang hangin sa piyak? Same na Japol. So, malain na aton nga consideration for AO and AG. Okay, based sa aton nga, no, na description from NCP, okay, ang value is, kung sa diin, receive sa positive external pressure. Okay? AO is the total area of openings in a wall that receives positive external pressure. So, if ever ang atong prevailing wind direction is blowing perpendicular to which, amo ni consider na nga area sa atong na wall. Meaning first na nga checking if atong building is open or partially enclosed. If ever we have checked both sides, no, sa atong na building as hindi siya enclosed, okay, let's say na-prove na ito, no, ang atong na AO is less than 80% sa atong na AG. So ang atong na building is not open. Okay. Kailangan na itong procedure for open buildings. Kaya ang atong na focus for this day, no, is the classification for partially enclosed and enclosed building. Okay, so how can we identify if ang atong na building is partially enclosed? If ever proven, no, ang building is not open, so let's check, no, next if ang building is partially enclosed. Okay, so as per definitions in section 202, okay, we can only classify our building as partially enclosed if both conditions will be satisfied. Okay, so first is the total area of openings in a wall that receives positive external pressure. Okay. Area sa bola, I mean area sa opening sa either hindi siya ka-blow parallel or ka-blow siya perpendicular. Okay? Exceeds the sum of the areas of opening in the balance of the building and below more than 10%. Paano mo siya ma-interpret? Exceeds the sum of the areas of openings in the balance of the building. So meaning, if we will have our windward wall, may openings sa other sides ng atong building, either sa leeward kasi iya nga side walls. Okay, if ever ang atong opening sa ina nga wall, no, is more than 10%, okay, so we can consider, no, atong na first condition pa lang. But we need to satisfy also our second condition. Na important na ang balance of the remaining openings sa atong building and below. Kaya ang atong na hangin, once magsulod sa building, okay, let's say this is our windward wall. So if dali magsulod ang hangin sa itong windward wall, and this opening ang siya gani, this is our AO. Okay, take note ang AO ang opening. Okay, ang AG, naman ang AG, is the gross area of this windward wall. Okay. So, manubal nga, if ang ating opening ko no, sa windward wall exceeds 10% no, sa total opening sa remaining sides sa building envelope na ito, nakakalawa ng building envelope, the exterior parts ng ating na building, so that is our side walls, may ang ating na windward walls. Kaya naman tabo, if we will have an openings there, these openings will allow mo ang sulod na hangin na mag-flow no? Sa outside part ng building or magbalik sa pakwa sa atong building. So if mag-flow siya, may possibility no, ng atong na hangin is mag-flow siya balik. Hindi mabilit sulod ng atong na wind pressure. Kaya ang hangin is magwa sa atong building. Sige lang, yan ang isang atong numerical expression. Then second, the total area of openings in a wall that receives positive external pressure. So for short this is, ano siya? AO. Di ba tayo AO gani? The total area of openings no, sa atong na windward wall. AG is the gross area sa atong na windward wall. So for condition 2, the total area of openings in a wall that receives positive external pressure exceeds 0.5 square meter or 1% of the area of that wall. Whichever is how can we interpret this?
Sir, 0.37 sa first printing.
Wala siya bilog 0.5 pad 0.37. Very good. At least na-range ng curve even. So we will have 0.37 square meters. Okay, wala ka bilog So di lang ma-burn or ma-supersede. Ang 0.5 or ang 0.37?
0.37.
Whichever is smaller. Di ba tatlo? Ang mahal niya, 0.5 square meter. Ang isa naman, hindi nakita ng 0.37. Section 202.
207A 1
Section 207A
1 2.1 0.2 Ah, wait. 8.2, sir. 8.2, sorry.
Hindi siya yan is under section
Ang mga po, sir?
202, di ba? Section 202. And ang ilang condition for 1% of the area of that wall. So for short, 0.01. Ano nga yung what? Ang naka-refer na is the wall that receives the positive external wind pressure. So ano na siya? This is our AG. So for our condition, if the total area of openings in a wall that receives positive external pressure, ano na siya? This is our AO. Check off. Okay. Exceeds. So meaning if this is greater than, okay, this is our second condition. AO is greater than whichever smaller. So dimension sa section 202, which is 0.5. Dimension sa section 278.2, which is 0.37, or the 1% of the gross area of that wall. Okay? So whichever the minimum. This would be our second condition. Okay, anong first condition natin? Let's interpret it.
AO is
the total area of openings in a wall that receives positive external pressure. Okay? So AO Japon.
Greater than
Okay, exceeds greater than
1.1.
Ilan ba niya? By more than 10% sa kanang remaining openings sa atong wall.
1.1 AOI.
1.1. Okay. So let's call this openings sa atong building. Okay, excluding atong windward wall. Okay. So let's call this as AOI. So this is the sum of the area of the openings in the building envelope, not including AO. So for short, ito yung mga hangin natin dali kasunod ang atin na hangin sa AO. Ang AOI is, amo na siyang iyang only exit path no, nga magwa ang hangin. Either sa aton side walls, sa aton na leeward wall, and sa aton na roof. Kung may opening ang aton roof. for short, ang aton na partially enclosed, we can only classify it if mag-meet na both, which is ang aton na 1, ang aton na AO is greater than 1.1 sa aton na AO ay. Take note ang AO ay nabari if di na aton na prevailing wind direction. So kung dali maguyot ang hangin, di na itong AO ay ari sa front sa building natin, ari sa rear sa building natin, at ari sa left side ng aton na building. So, ang aton permit na basihan is diin ang aton na prevailing wind direction. Okay? So, for clear, regarding AO, AG at AOI.
Sir.
Questions? Okay. This is for partially enclosed. Only one. Recap that. Paano naman balik open ang building?
If
ang aton na
AO
opening sa windward wall is 80% sa gross sa ating wall. So we can consider that as open. Okay. So if ever proven, no?
For all walls, diba sir? Sa open, diba sir? For all walls?
For all walls. Kung di receive positive external.
Kaya sa 207, pag it's 0, each wall is at least 80% open.
Remaining walls, bakit? Okay, each wall. So, i-check lang natin na windward kasi if dali maghuyap ang hangin, if 80% of the opening is greater than sa ating gross, and sa ating dali na perpendicular to which, if the opening is greater than 80% sa gross, we can consider our building as open. So, more likely, wala na building na open if mga residential or commercial. Usually, mga open buildings are mga covered courts, so kaya ka lang din magamit.
Ano yan sir, kung makasipay siya sir nga partially enclosed sa kung padiribing hangin niya pag wala siya ga-satisfy sa conditions yung dirig.
Dapat i-satisfy mo both the for open. So dapat kung one side of the building is not classified as open, you can classify this as partially enclosed. Kaya nga itong consideration for open is wala may mabilin na internal wind pressure sa sulod. Sa baga, pag sulod sa hangin, magwa sa dayon. That is an open building. Amo na nga ito na principle. So, an open building, pag sulod sa hangin, wala may mabilin nga hangin sa sulod, magwa siya sa inyong remaining walls. For partially enclosed, magsulod ang hangin, depende if pila bilin na mga areas ng walls sa remaining natin na sides ng building envelope na. Okay? And anong last? If ever, hindi natin mag-meet both conditions for partially enclosed, that is an enclosed building. Sample problem or wala? Sumata na yun? Sumata. Gamitan daw ang sila ng ventilator. Sumata. Nabikot na ako ng fast space, no? Sabi din, nakikari na ako magpaliwan. Prelim exam, set A.
Bad memories. Bad memories.
Okay, problem set number 1. Okay, a building has the following gross area of the walls and openings specified sa the table. Okay, so determine the building enclosure classification. So we have here, okay, ang location sa mga walls natin. So may mga gross areas, may mga openings na. Okay, yan the points. Okay, so that's the letters of viewer RCB-PE-01. Okay, kali siya. Okay, so atong na prevailing wind direction lang siya. Din siya huyop. So we will have our front wall, kaya sa right side wall. So meaning, ang sa likod that is our rear wall and ating left side wall. Clear. So go yung mga hangin sa din, sa right side wall. So we will consider this area sa wall na to for our AG and A. Okay? So from the figure, we all know hangin is blowing perpendicular to ridge. Then, go yung sa itong right side wall. So that's the letter sa itong table. Okay? Okay, so let's identify ang ating mga table. Okay, so we have there 5 parts ang ating building envelope. Sa liwatan ng building envelope, ang exterior parts ng ating building or the exterior faces ng ating building. So we will have our front wall, rear wall, right side wall, left side wall ng ating roofing. Okay? So din yung panghangin natin ang sa ating right side wall. So we will consider AG as ano? Ilan na AG? So that would be 396 square meters. Okay, next, ang ating AO. Anong AO na niliwat? This is the area of opening mag-receive sa external na positive wind pressure. So that is our right side wall, which is ang total opening sa bilang? That is 42.2. Bibinig pa tayo. Bilang aton AOI. Anong AOI gani? Is the area of openings no, sa ating building excluding ang aton windward wall. Okay, paano na siya? So that would be ang aton front wall 10.8 plus some rear wall natin which is 4.32 opening. Then ang aton left side wall which is 21.6. Pila ni ang aton AOI? 36. Pila? 36.72 square. Okay, clear? Wala si AG. So, ari atong expression sa description earlier. So, for number 1, diba, the total area of openings in a wall that receives positive external pressure exceeds the sum of the area of openings in the balance, the building envelope by more than 10%. So, this is the AO is greater than 1.1 AOI. First condition. Okay. Then, for number 2, the total area of openings in a wall that receives positive external pressure exceeds 0.37. Okay, area ito na 0.37. But under section 202, may hapos ang ito na 0.5 square meters. Okay, then, and, gusto ko pa siya, and the percentage of openings in the balance of the building envelope does not exceed 20%. Okay, percentage, tumingin third condition and the percentage of the openings in the balance of the building envelope, meaning percentage ng opening in the balance of the building envelope. Percentage ng openings ng balance
AOI over AGI.
does not exceed 20%.
AOI over AGI.
Ratio sa aton na AOI, ang openings ng remaining sa baga ang windward side, kaya remaining walls atong excluding windward side ang iyang openings in ratio sa iyang gross area. Okay? So, anong AGI? I-add ko lang. AGI is the gross area of the envelope excluding windward. Okay. Ang remaining ng gross area. So may fourth na nga element. So this is our third condition, which is AOI over AGI. Okay, that is less than or equal sa 0.8. Okay. So these are our three conditions for partially enclosed. Okay? Gilugang ko siya kay ang ating na-given, gamitin mo na later on ang ating na-AGI. Okay, so let's go back with it. So, para ito masumang ating na-AGI, Anong AGI what? This is the gross area sa remaining walls natin or envelope na excluding aton nga windward wall. So that would be aton nga front wall which is 138.6. Then aton nga rear wall which is 138.6. Plus ang aton nga left side wall, kasi syempre nga receive is the right side wall. So plus 396. Then ang aton nga area sa roof which is 376.8. Aking question, Sir, paano kami magsuma sa area sa roof in case wala ka naghatag calculation? Anong area? Is it the projection? Okay, maybe two types of area sa roof. Okay, if this is our roofing, okay, iapat na area which is considered ang plane sa roof. Okay, in the area nga iya plane. And ang second is we will have a projected. So we will have a vertical projection ng area. This is the area nga projected. Maglantaw sa top view na sa inyong floor plan. Okay? Diba si kayo hat tapos floor plan, tapos may roof framing plan. Makita ninyo is amuning roof. Okay? So masuma nyo immediately ang inyong area projected. But ang gamito na area sa roof dyan, ang yung gross area is the area sa aton na plane. Okay? Okay, we are considering no, ang ratio sa aton na openings over the gross area sa envelope. This is not the envelope of the building, but ang area aton na inclined plane. Okay, this is not the area, but rather ari ang aton nga inclined plane. Okay, so dali mag-test ang inyong plan reading kung paano kamo mag-interpret plans. Muna nga ganito pakita na kapos ang plans, kay later on that plan no, kung nang inyong gamiton no, magsumat sa aton nga design windows for your output for prelim. Okay, take note ang aton nga area sa plane not the projected. Okay, kabalo ko halos na nang ilan no baga oy kita for roof framing. Tapos no 4 agwas. Ang area sa roof. No. We must refer sa iya nga area sa plane not the project vertical projection na. Okay, clear name? Let's go back sa ating computation. Okay. Okay, so what would be the first step natin in order for us to classify if the building is open, enclosed, or partially enclosed? So first, check if building is open. So paano pala if building is open? Bukas na ang door. Okay, anong condition na natin? The building is open if ang ating na AO is greater than 80% sa ating na AG. Okay? So let's compute 80% AG. So AO is 42.2. Okay. Ang na AG is 0.8 AG.
396. 316.8.
316. Okay. Is this greater than or less than?
Less than.
So this is less than. Okay. Therefore, building is not. So wala so wala. Okay. Next, check. Okay, once again, nga gani pina-check ta if anong enclosure classification natin. Anong reasons na pina-check na siya. So, nabalaan natin if we can use this equation. Okay, this equation can only be used for partially enclosed and enclosed rigid buildings. Kung muna pala sir, kung ma-prove ko na siya hindi siya ma-open, automatic, hindi na siya. Okay, but what is the point na kinahanglan naman natin yan if partially enclosed or enclosed? Okay, later on, sa ating equation na GCPI, lain ang GCPI sa partially enclosed sa enclosed buildings. Okay, so let's check if the building is partially enclosed. Anong first condition natin? Okay. AO is greater than 1.1 AOI. Okay, so let's check ang 1.1 AOI natin. Pilan siya? Ilang AOI natin? That is 36.72. Pilan eh?
40.392.
40.392. Square meter, ano na? Okay, is this greater than? Ilang AO natin? 42.2. So 42.2
It's greater than.
okay, this is greater than 40.392. Okay, therefore okay for first condition. Therefore okay siya sa first condition pa lang. But this doesn't signify no nga partially enclosed na kung nabibigay. Anong nabalian? Dapat all conditions must be met. Okay? For number 2. Okay, anong second condition na natin? Under sa inyo ng CP. Ay siya diba? AO
Is greater than.
Sa atong na 0.5 square meter, 0.37 square meter, at 0.01 AG, whichever is smaller. So we will select minimum value. So for short laser, mag-burn ko sa aton na section 2 at section 2.7, okay, na provision is the 0.37. Okay, so let's check. Di na mag-burn na duwa. Okay, so let's complete for our 0.01 AG.
3.96.
3.96. So nang nag-convert ang aton nga 0.37. Okay, so AO is milan 42.2. Okay, and this is greater than sa aton na 3.96. Okay. Therefore, okay for second division. Okay, take note na wala ko lang yung dami units, ay same lang mantanan, area. Okay, last. Okay, which is AOI over AGI. Okay, this is less than or equal to 0. Okay, pila ito ng AOI ganit? 36.72 over AGI, which is ilan ito? 1,000 in
1050.
Pilan eh? 0 point is
AO. 0.03. Ano na?
Minimum diameter 0.37. Kaya ang user
akin diba? Ilan ako? Okay na, okay na.
Okay na, sir.
No hard feelings. Ayan, kapilan eh?
0.035.
0.035.
35.
Ano na siya? Less than or greater than?
Less than.
Less than 0.2. since all three conditions are satisfied, therefore building
It's partially enclosed.
partially. Kung isa hindi okay, therefore building is
Enclosed.
okay. Tapos lang. Siyempre, enclosure specification lang ang atong nga point 3 is the minimum design loads. Okay, so subong aware na kamo how to classify if the building is open, partially enclosed, and enclosed. Okay? So you can now identify which type of formula or approach or method specified in the CP. Okay? So for our section 07B.4.1, we need to identify if the building is rigid or
flexible.
flexible. Okay, so how can we identify if the building is rigid or flexible? I know gagamit mo sa frequency, say mga 31.
Yes, sir.
Ano di ba frequency? Okay. So, recall natin. From your theory 1, how can you identify if the building is rigid or flexible? Ilang frequency na? If greater than 1, is it rigid or flexible? Rigid, greater than 1. If less than 1, that is a flexible building. Anong reason? So, di ba ginansion ka earlier, ginagamit na ang gas effect factor, di ba? Or ang atong gas effect, there is an event sa atong yung pressure na reduce ang atong relative pressure in terms of evaluation sa building. Take note niya, if ang atong structure is experiencing lateral loads or resisting lateral loads, there will be vibration or oscillating. So what do you mean by oscillation? Sa inyong mga physics. Pag obvious ang one direction, kabalik siya into its original na location. So ano mga mga frequency?
The amount of
period. Frequency. Sa boards ko lang. Frequency, anong period? Anong mga frequency? The amount of, ano ganit? Anong frequency? Di ba period is a total period ng building kung mag-sway siya makadto din, makilid. Okay, ano ang starting point? This is the starting point. Kung mag-sway siya, tapos mag-sway siya pabalik, okay, then ang balik siya nga original na position. That is the period. Okay, anong frequency? Amplitude.
period over time.
Mentioned earlier, anong hertz na eh?
Per second, sir.
Sakit, no? Hertz. Off the record. Diba frequency are expressed in hertz?
Sir.
Sakto. Ano mga bata nga 1 hertz?
1 time per second.
Ha?
1 period per second.
For sure, this is 1 over t ang ating na. Sakto. Okay, so ang ating na rigid description, ang ating na building is rigid if its natural frequency or F, okay, as per NCP, times wala naman derivative. will dwell on this deeper sa aton na seismic regarding frequency and period. Okay. But for now, no, at least aware ko ang atong frequency and period are correlated in terms of the oscillating effects ng atong external or din atong lateral load sa atong building. Okay, so sa liwat na kung maguyop ang hangin sa building, may possibility na mag-vibrate ang atong na building. Okay, so if ang iya na frequency is less than 1, okay, so we can consider, aking question ko, if ang frequency is less than 1, diba we all know this is rigid. Paano siya mag less than 1? From our equation na 1 over t. Dako ang t, diba? So meaning lawig siya mag-sway. Okay? So it will take a longer time mag-sway siya pagbalik niya sa iya na original position. Okay, sa more than 1 second. Okay, that's why if less than 1, sulit no? Less than 1 rigid or more than? Flexible eh. Sakto yun eh.
Yan sir.
Sakto na.
Ay nakaambal, sir nga as defined by 207 8.2 pero wala man diyan.
If the frequency is less than 1, the building is flexible. For what reason? Ang iya nga period is lawig. Kung mag-sway ang building, di ba kung slender siya, lawig mag-sway. So it will take a longer time. Thus, less than 1, this will be a flexible building. If ang aton na frequency is greater than or equal, di ba? 1. Aton na building is rigid. So meaning dasig lang siya mag-sway. Okay? Shorter amount of time ang aton na value diri is larger than 1. But we won't use this. We will have an alternate way. Okay, most of our building or most of the building na inyo i-analyze is a rigid building. Okay, ang approach natin for flexible building is more complicated. Okay, we will have spectral analysis which is hindi natin ma-cover din, but ang focus natin for CERCDN is low-rise building or rigid buildings, no, na partially enclosed or enclosed building. So how can we identify if ang ating na building is a rigid building? So let's refer sa ating na section 2.2. Okay. Okay, if the building is low-rise,
natural frequency less than 1 Hz, flexible. Ano?
So we won't use we won't use frequency to determine if the building is rigid or flexible. But rather, we will use this definition, section 207, 8.9.2. Okay. So ang bago no, low-rise building as defined in section 207, 8.2 are permitted to be considered rigid. So as long as inyong building is low-rise, okay, pwede siya consider as a rigid building. So for short, anong nga high-rise building, ano sila? More likely, they are flexible buildings. And complicated plus ang analysis no, sa mga flexible buildings, lain ang iyang response in terms of flexibility kalang iyang translation. But rather, let's focus on mga rigid buildings wherein we will use that approach, which is section 270.4.1 for rigid buildings. Okay? Anong first condition natin? We can consider it as rigid if that is low-rise. So how can we identify if the building is low-rise?
Mean roof.
Kung low ang building. Okay. So under section 2.2, we can consider that the building is low-rise. Okay? Take note that is an enclosed or partially enclosed building. Okay? Basahan ito na diba sa aton na method kanina na target. Okay? Which complies with the following conditions. The mean roof height h is less than or equal to 18 meters. Okay? And second, okay, mean roof height h does not exceed this horizontal dimension. Okay, so let's define first what is mean roof height.
Nag-record lang ako party sound, sir.
Basta mag-drawing ba tayo? Pero hindi sila nga nila ko 3 days. It's my son. Tapos may dayon yung puno, di ba?
So na may tawa sa kilid.
Feeling artist din. Anyway, nakita na rin sa atong naging roof height, kag-in height. Okay, take note, ang atong na roof is composed, no, halin sa bottom part sa atong na roofing or roof truss. Okay, takad ko sa atong na, ang tawag sa isang highest point ng roof, this is our
Ridge.
apex. Okay, anong tawag sa isang bottom part?
Eave.
Okay, this is your eave. Okay, and take note also that initial na height, ang sa dalo, is still considered as roof height. At atong na highest point is still also the roof height. Okay, ilog na roof din siya. Ang atong na bottom height or bottom elevation sa roof, ang atong na highest elevation sa roof. So what do we mean by mean roof height? Ang average ng atong na eave height kag apex height.
Except for
Gets?
sir. Pero may exception, di ba sir? Di ba may exception, sir?
May exception. Okay. Diba ta? Ang mean roof height natin is the average ng apex height kag eave height. So for short, middle nila. Hindi siya ang center, hindi ka triangle lang. Okay, but rather middle no, sa ating na apex at eave height. So this would be our mean roof height. But there is an exception. Okay. Ang atong na roofing, okay, may ang sinatawag na this is our pitch. Okay, may pitch na. Okay, so let's refer sa definition sa atong na mean roof height. Okay, under section 2. Okay, mean roof height. Okay, section 2. Diba ta? Mean roof height is the average of the roof eave height. Kaya ang roof eave height, average siya, ang atong na eaves or bulada. Okay? And the height of the highest point of the roof or atong na apex, except that, okay, if ang roof angle nato is less than or equal to 10 degrees. Okay, so two conditions. So atong na mean roof height, okay, if ato lang yung balya. If ang atong na angle, ang angle ka, or atong na roof pitch, okay, ano siya? If that is greater than 10, that is the average ng atong na MRH kag ano tawag ka din sa apex height mo? Maximum height. Average na lang. Okay. And if ever ang aton na roof angle is less than or equal. Okay, take note nila ang mga equal. Okay, 3 kilo sa mga part. What if we have that 10 degrees? Exactly. Anong answer? We will use the roof eave height. Sakto?
Sir.
Okay? So if ang atong na angle is greater than 10, okay, so we will use no, ang average sa atong na apex height kag mean roof height. If ever atong na roof pitch is less than 10 or equal to 10, we will use the roof eave height. Anong reason? Tamaan na kanubo sa atong na roof to be considered no, na ang atong na roof height is at the average. But rather, we will use the conservative na atong na roof eave height. Okay? So this is to identify ang atong na mean roof height. So let's go back ang atong na sa ating discussed earlier, which is an rigid building. Okay? So liwat the building is low-rise if ang atong mean roof height is less than or equal to 18 meters and ang mean roof height does not exceed the least horizontal dimension. Okay, let's say this is our building. Okay? So what ang building envelope excluding ang atong na roof. Okay, so this would be our shorter side, let's say B. And ang atong na L. So we'll call this mean roof height as, ano natin yan? This is your H. Okay? So duha kondisyon, no? the building will become low rise if first, ang atong na mean roof height na siya less than or equal to 18 meters. Second, ang atong na mean roof height na siya does not exceed. So kung nag-equal siya, na-exceed sa wala?
Wala.
Wala. Less than or equal sa atong na least horizontal dimension or ang atong na B. Imo ko na lang siya B. Okay? Ay siyang B ah. Okay, later on sa atong na windows, we will consider B as the shorter side sa atong na building. Ang L is the longer side. Less than or equal to B, less than or equal to 80 meters. As long approve mo ni siya, the building is low rise. And if ever the building is low rise, ano siya?
Rigid.
The building is rigid. So we can use this provision for our design wind pressure. And most of your project study will fall under this.
Most.
Unless gusto mo yung building will become a flexible building, you can use no section 270.4.3 ang flexible or 0.2. Okay? So mata. Quiz number 1. Meaning certain what we want, yes, different of what we want. Okay, number 2. Determine if the building shown in figure RCD PQ01 is low rise or not. Di ba PQ01? Ano siya? Okay, so let's determine if the building is low rise or not. Okay, the building is low because kaya na, kailangan na recycling test or sa figural. At rather, kung hindi ilang kapili ka 15, kasi 15 steps. Okay, example number 2. Okay, so we have there our building. So how can we identify if that is rigid or non-rigid? Mag-base sa ating nga conditions, no? Okay, so nang given dira. Ang ato lang nga dimension. Let's try to solve. A given is figure, no? So let's draw our roof. Take note na regular, dapat na to. Zoom ko lang gamay. Okay, we'll solve first our roof height.
Low rise.
Okay, so atong na front side sa building, it has a width of 25.2 meters. But ang atong na roof, ilang total span niya? That is 25.2 plus 2 times 0.75. Ilan na? Ganun. 26.7. Okay. So let's check first ang computing for atong na roof pitch. Okay, tinatang data. Okay, so how can we compute for our data? If tangent. A big one. So bilang height natin? That is 2 meters. 2 all over ilan? 0.5 times 26.7. Sir, what if sir wala ko yung drawing figure? Okay. Pila na siya? Nakita?
8.5 degrees.
And this is, ano na siya? Less than sa aton na 10 degrees. Tapos lang, siyempre hindi. Kaya nga what if why nung ilantaw ang bulada? Naglantaw na 25.2. O ay makita niyo ang 0.75. Ilantaw na ito ni 5.2. O check natin. Tangent data, let's check Tabo ko na biktima last year. 0.5 times 25.2, pilang height? 2, pilan eh?
9.01. 9.01.
25.2. Ha?
Ay, wait, sorry.
Ilan? 9.0. Ano na yung given? Sa example, sa example. Okay, kaya sa one time na greater than, kung ako nagamiton, ito naman. Take note na malainay siya. So always consider ang inyong span sa roof, not the building dimension. Okay, possible let's say di na gamay-gamay siya. Ang atong data, if ang atong building dimension is greater than 10, so pwede mo siya mahambal na the building is not lower. Okay. Since data is less than 10, h is equals to 8 Okay, bilang ato na h, that would be 17.5 meters. Okay? Okay, what is greater than 10? Paano sumaw lang ato na h? Ang gawin sa ato na id height kag total na ikas height. So always refer sa ato na roof pitch. Ano after sunod? Since we already have our mean roof height, okay, so let's check if building is okay, how can we check? What is the first condition na H is?
H is less than 18 meters.
Less than or equal to 18 meters. O, aking problema. What if pag suma mo sa theta, this is greater than pila? 10. Anong gamitan mo nga H? Pilang average yun eh?
18.5
plus 1.
18.5.
That is 18.5. Dahil na greater than 18. So makonclude ka ng building is not motorized. Basta na.
Hindi pa guro sir?
Hindi, parang ito both need niya emit. Okay? So H is, ano siya? 17.5 is less than 18 meters. Okay, therefore, okay, sa first condition. Okay, second condition, H is less than sa ating B. Kailangan ng B. That is 25.2. Okay, so 17.5 is less than 25.2. Okay, therefore, na-meet din it. Okay. Since both conditions are satisfied, building is low rise. What if ang question, identify if the building is rigid or not rigid? O, dapat ka since. O, since the building is low rise, building is rigid. Woodline CERCDN, hindi.
Puti yan.
Sa atin ng mga easiest part. Okay. Questions?
None so
Sir,
far.
what if kung flat ang roof? Kila ipotata? 0. Wala sa roof deck ka. So 0 siya. Tingnan naman kami ito naman sir na height. Ang height sa inyo nga, roof deck. So what if sir may parapet wall? Hindi mo pwede, di ba, roof deck mo, wala parapet wall. Di ba? Roof deck ng building. O, may tao ka dire. O, di ba dapat may parapet wall? Ano may parapet wall? May parapet wall. Okay, maglumpat na naman si Raquel. Ano yung consider na mean roof height? Di ng roof out, ang wall hindi. Di ba ang wall hindi siya roof? Okay, nga itong roof. So this would be our mean roof height. Okay? Okay, ano nga sir yung consideration for our parapet wall? We will use, no? Section 270.4.5. Okay, we will have conditions for parapet walls na inang iya na occupations. Okay, clear? Part. Okay, so that's just identifying, no, if the building is rigid or flexible. Okay, second, enclosure classification. Okay, once identified, no, if the building is partially closed and enclosed, then you have proven that the building is rigid. We will use this pressure equation, okay, which is introduced last time. So this would be our external pressure, and this would be our internal pressure. Okay? So isa-isa na. Data mauna. Q. Now si G. Okay? So G is our gas effect factor. Okay. So under section 278.9.1, okay, the code specifies that the gas effect factor for a rigid building. So since we have already identified na the building is rigid, okay, so we can take, no, ang atong gas effect factor as 0.85. So all the time ang atong na G is 0.85. Regardless if windward, leeward, or side walls, or even roof, ang G is always fixed. Okay, hindi ma-differ ang ating mga values ng Q. Let's see. Okay, so let's identify our 4 directions. We have our windward. Leeward, atong na side walls, and lastly ang atong na I think ang roof hindi na malapot. Lain na siya na discussion for the next meeting na kaya mas complicated sa roofing. Okay? So let's discuss first. So what is the effect of our wind pressure for the windward wall? Anong atong consideration galing? Okay, so for our windward wall, okay, ang atong na value sa Q, isa-isa ta, ang value sa Q natin is equal to QC. Okay, madala yung QC. Then for leeward wall, ang value sa Q natin, using this equation, this equation, this would be QH. For side walls, gamiton tayo. Ang aton na Q is equals to QH. And for our roof, ang aton na Q is equals to QH. Okay. Mal-record na ba? But take note, ang aton na G is the same sa tanan na sides ang aton na envelope. Okay. Second, ang atong na CP for windward wall. Hindi na siya makitaan. Yes, sa NCP. But in sa NCP. Ayan. So this is figure ano eh? Figures na makitaan sa page 2-74. Sakto? So these are your wall pressure coefficients. Okay. So for windward walls, tanan lang ang CP bilang. This is 0.8 positive, no? For our leeward wall, ilang CP na? Leeward. Depende, no?
Depende sa lower
Depende sa
visit.
ratio. Check ang ratio sa longer side ng building over its shorter side. O for side walls, ilang ato na CP?
Negative 0.7.
Negative 0.7. So take note ang ato na CP. It is the range from negative 0.2 to negative 0.5. Okay. Clear na? Pinisa-isa na. So, we now have our G, okay, we now have our Q, okay, we now have our CP. Okay, so for our roofing, okay, ang iyan nga CP, we will discuss this by next meeting. Idamot na cases sa aton na roof. Okay, so di siya kaya sa aton na short discussion lang. Okay, then lastly, ang aton na external and internal wind pressure, no? So how can you quantify this? So as per NCP, ang inyong QI, gamitin mo ang inyong QH. Okay, yan siya makitaan. Under section 270.4.1, check na biliwat kung sakto binawakal.
Sir.
Sakto hindi? Sakto ulit. Sakto pang memorize ka. So QI is QH. Okay, number 3, QI of QH. O say na nila eh. Lastly, ang atong na 4. Okay, anong GCPI? Okay, take note ang GCPI is one variable eh. Hindi na siya G ah. Hindi ba sa atong formula na sa NCP, wala na ka muna. So kasi masalaan mo ang G as decimal factor, but rather this is GCPI. Okay? So before we proceed sa itong Q, okay, let's discuss GCPI. So since we have already identified what type of enclosure classification of the building. So this can be from section or in table
278.11-1.
Okay. So since this procedure is only applicable for partially enclosed and enclosed buildings, okay, ang GCPI is equal to for enclosed that is positive, negative 0.18. Okay, this is for enclosed. What do you think is the reason na aming positive and negative gani? As mentioned sa previous discussion, ang atong internal wind pressure, pwede sa mag-uyok, pwede siya mag-suyok. Okay. And if partially enclosed, that is positive, negative 0.55. Ang question to, sa open buildings, ang GCPI is 0. Kaya magbuha ang sa building. That's why important with ang principles regarding internal and external pressure sa building natin. Okay? Isaliwat, ang internal pressure is the effect sa nabilin na hangin sulod sa building. If ang atong na building is open, ganang na hangin na sulod, magbuha siya. Okay? Wala siya nag-stay. Okay? So clear na? Complete na? So ang values ng atong na P, vary siya if ano gina-analyze ng envelope sa building. Either windward, leeward, side walls, or roof. So for now, let's discuss ang mga walls lang. paano butang sa pressure sa aton nga walls. Okay, ang question, naa sa windward QC, nasa aton nga leeward ug side walls, QH siya. Okay. Diba last time ang upside nyo, i-assume sa dati ang windward wall is uniform iyang distribution. Diba mo? Going parallel to which? Front view. Okay. So take note. Atom na Q, this is our velocity pressure. Okay, ano sa liwan na itong velocity pressure? Amo ni siyang gross value sa aton na wind pressure. For short, ang aton na Q, ina-reduce natin with the effects ng gust. Okay? Since ang aton na building is double break, hindi siya 100% ng iya na ma-resist ng velocity pressure. Then we will have our CP or the external wind pressure coefficient. Kung anong kasi yung windward wall, siya may pinakadakot na CP. Kaya siya first, characteristic sa inyong wind pressure. So, samtang napalayo, paglabot sa side walls, nag-negative 0.7. Paglabot sa inyong leeward wall, kalabot 0.2 to 0.5. Sa liwat, yung aton na hangin is the flow. Okay, that's why ang aton na rho, na value sa aton na velocity pressure is reduced by your gust effect factor and external wind pressure coefficient. Okay, then ang effects sa aton internal. So, we will discuss separately internal. Okay, mas dalo ni siya. So, let's discuss first ang effects sa aton na external. Okay, akin ang question ko. Naami QC, naami QH. Okay, so let's discuss ang aton na definition for Q. Lagyan sa piyakan. Okay, so ang aton na Q is equal to 0.613 kz, kzt, kd, p squared. Pinalang ko na CP. Or so far, wala pa na class nagwasan. Of course, ang videos. Ang trend subong is earthquake. Okay, so expect sa earthquake natin na medyo dalong siya. So may salubon. Ito muna sa earthquake. Okay, don't worry, you will have also earthquake engineering. Ang mga advantage, no, if nag-specialize na sa structural engineering, kasi examiner subong, mahilig na pagwa earthquake na mga terminologies. Okay, so sa inyong second sem, you will have an elective na earthquake engineering. So mag-discuss in depth regarding sa aton ng mga earthquake ng mga procedures. Okay? Proceed na rin. Ay question naman na 0.613 eh. Pinagbasa sa NCP wala sa 0.613. Diba this is derived from the unit weight of air? Okay? So this is not arbitrary.
At a temperature of 15 degrees Celsius.
At pila na natin sa picture?
15 degrees.
15 degrees Celsius. First element, ato na KZ. Ano si KZ?
Velocity pressure. JC niya, sir?
As KZ, mabalinan. KZ. So let's discuss first our KZ. Okay. So yung KZ is the velocity pressure exposure coefficient. Okay. So aton na wind kuno based on exposure, pwede niya i-amplify ang aton na wind. Either kung direct sa inyo madalog sa tuta or kabaw sa inyo ka building. Okay. So this is ano yung KZ? Velocity pressure. Di ba nung Q gani? Ang Q is the velocity pressure. But, ang iyang gamit na term is the term na exposure. Pwede siya. Okay. So, ga-matter to no, kung diin ang location sa atong na building para ma-amplify or ma-reduce ang value sa atong na velocity measure. Okay? So, sa liwat, ang atong na AZ will be categorized under 3 exposures. Okay? Which is exposure B, exposure C, at exposure D. Okay? Kasi maniman, o ka mo top to bottom ta. Nag-uuna ka sa atong formula, pataas na padalo. Okay, diba under sa steps natin diyan? Ano yun? Diba first, identify exposure. Okay, there we will start from our last formula. Okay, so for our basic, liwat that from the name itself, the base sa iya na exposure. Ang unang yung keyword, basic, based sa exposure. So we'll have 3 types of exposure. Exposure B, exposure C, and exposure D. So how can we identify if ang ating exposure is B, C, at D? So nga wala A. Sige, may nga wala A. May pagkita. So for our exposure, to make this simple, exposure A, right, and exposure B. Okay, this is just the requirement if you will satisfy the surface roughness. Okay, ang atong exposure C, if you can satisfy the surface roughness C. Exposure D, if you can satisfy the surface roughness D. Ako rin before, same name. Ano siya? Okay. Sige. So let's discuss our surface roughness. Surface roughness. Okay. So we will have 3 types of surface. Okay, surface roughness B, C, and D. Okay, so for our B, these are all buildings located in urban or suburban areas. Hindi na, ano niya effect or ano niya uniqueness in terms of exposure B. Let's say this is your building structure, no? Ano yung building? Ano pa lang? Kaso located siya sa urban areas. Ang urban areas is, ano na siya? Filled with a lot of another buildings, man, di ba? May building ka din, eh. Building ka man din, ah. May building man din, eh. Anong iyang unique principle din? If maguyop ang hangin, hindi siya directly ma-resist sa imong building. Malabay pa siya sa other buildings, ma-flow din ang hangin. Hindi ma-flow din, ma-flow din before makanto sa imong building. So for short, ang inyong path sa hangin is mas rough siya compared sa inyong other na exposure or location. So ang imong hangin, hindi siya mag-flow directly. But rather, no, may ka sa roughness. Maybe consider roughness kung ano ginagyan sa hangin before yan malabot ang imong building. So for urban or suburban areas, no, kung ano ang imong gross na velocity, pilibang ato na translator is the basic wind speed. So gina-reduce ang atong na kz ang atong na value sa velocity. Kung mas damok building na kahuyop dire, paglabot sa imong building, hina na ang hangin. That's why ang term niya is roughness coefficient. Kung sa baga may ka-friction sa imong hangin before siya maglabot sa imong building. So that is surface roughness B. Urban or suburban areas or wooded areas or other terrain with numerous closely spaced obstructions. So sa baga, imong hangin i-lessen niya before magkanto sa imong building. That's why for urban areas, rare lang sila maka-experience problem in terms of strong typhoons. Kaya ang hangin na gahuyop is before maglabot sa imo, gina-resist sa aton at sa other buildings. Okay? Next, surface roughness C. Okay, so this is open terrain with scattered constructions having heights generally less than 9 meters. So mga 2 to 3 story lang. Okay, so yung mga anong sulit ng urban kanina? Non-urban areas.
Rural.
Rural areas. Hindi siya open space. But rather, no, before maguyap ang hangin, may jutay lang ng mga scattered buildings. Okay, may building dali, may puno dali. Okay. So mag-flow ang hangin, hindi siya directly mag-blow directly sa building, but may mga roughness pa siya nalabyan before siya maglabot yung hangin. Okay. And lastly, ang ating surface roughness D. Flat, unobstructed areas, and water surfaces. Let's say open field ang imong mga building. So more likely, ang imong nga hangin, no, kung maguyot siya from one direction, wala sang other obstruction no, na mag-lessen sa iya nga magnitude. Okay? So kung naman notice ninyo, from surface roughness B, more likely, ang iya niya reduction factor is greater than compared sa ating surface roughness D. Okay? Kaya nga, mas damo siya sa obstruction dire na mag-resist sa atong wind pressure. So let's check our NCP kung sakto ng gito. Try to observe ang atong mga surface exposure. From height na 0 to 4.5, ano yung surface roughness B? Diba mo na siyang exposure wherein damo urban, damo buildings. Dako iyang reduction factor, gina-reduce niya by amount of 43%. Pero kung open ka, i-magnify pa lang yung instead of 1, ang imo nga basic wind speed, i-magnify niya by 3%. Kaya open, kung sa maghuyot sa hangin, wala na other obstructions na mag-resist siya before maglabot sa building. This is the importance of our velocity pressure keyword and exposure coefficient. Kung na kung imong exposure B, gagmay imong KZ, may damang obstruction. Okay, as you go towards no, mag-open ng imong exposure, gagako ang imong KZ. Okay? Principle. KZ ng danay. Let's proceed. KZP. Ano sa KZP? KZP is your topographic factor. So, let's exposure sa topography. Exposure is ano nga buildings ang kasarap sa imong structure before makuyok ang hangin pagkato sa iya. Ang inyong topography is if the allocate no topographically. Okay? So, nga kasang reference elevation. Topographic. Okay, actually, inyong building, the matter siya if din siya na-locate no, either sa imong flatlands no, or grasslands. Okay, if this is your building, okay, then flat lang imo nga surface, no, imo nga topography. Pagkuyok sa hangin, wala kasang magnification. Okay, thus, ang imo din na hangin nga V, paglabot dali sa imo, V man na siya Japan. That's why most of the time, ang value sa atong KZP is equal to 1. Kaya rare lang ta mag-design sa building na may ara sa high topography. Kaya nung tabo, sir, if line ng atong topography, let's say, imo nga building is ara sa mga ridge or escarpment. Let's say, okay. Or di mo balay. O paguyok ng hangin dali, okay, may ara ka build up pagsakat nimo. Okay? So, may ara sa factor, no, either may increase siya. Okay, I think may increase siya. Third is speed up. May na visualization si NCP. Kung may escarpment, pag yung mag-ibong hangin kaya, there is an increase sa ibong velocity pressure. Okay, but most of our buildings, we will consider no, nga flat topography or ang KZP is equal to 0. So take note that ang KZP is the, ano na yung KZP?
Topographic factor.
Topographic factor. Kaya ang reason na always 1 siya, ito we will consider flat lang topography for our building. Okay, unless no, design na building is above no, sa mga cliffs or escarpments, so you consider KZP na more than or greater. Okay, lastly, anong KD? Kilid dala. Ano na sa? Wind directional factor. Eh, di ba na yung first step, di ba? According sa NCP. Wind directionality factor. Okay. So, nga itong KD na base if what type of structure no, ang atong nang design. Okay. So, manotice ninyo, ang atong na buildings, Okay, ang ER reduction is around 15% lang. Kaya ang atong na shape sa building, ang portion ng atong KD is based on the shape of our building ng ER component. So, paano mag-direct ang wind from the windward side going sa inyong side walls kag leeward walls. That is from the keyword, no? Wind directionality factor, or ano ba yung atong first method? This is the directional procedure. Mag-flow ng hangin, halin sa inyong windward wall, magmayas ng 4 directions wherein matransfer ang wind from the windward side going to your leeward and your sidewards. So for our building, since atong na building is closed at all sides, ma-flow easily ang atong na wind from your side walls going to your leeward wall. O, i-compare ninyo sa atong na other na mga structures. Ilang ang easy. So for our truss towers, halos 0.85, diba? But ang mga chimneys and tanks. Why do you think ang reason nila is mas tako? For round that is 0.95. So more likely, ang nose ang hangin, no? Hindi, wala siya may ginahaboy pagwa, or wala sa may ang iyang resistance, no? Gina-resist niya almost 100% compared to your buildings. Sir, paano sir, truss towers, 0.85. Di ba sir, truss towers, open siya, the-flow ang hangin. Hindi. Ang inyong members will resist, no, your windows. Okay? So, we can discuss paano mag-ang windows sa inyong truss towers. Okay, this is RC design. But if may enough time ka, okay, I can share to you paano mag-open sa windows sa mga trusses. Later on, may time ka. Okay? So, complete na. KZ, KZD, tag, KD. Okay? So, inyong KD ka base sa ito na structure type. Okay? And take note, ang inyong KZD ka KD, these are always fixed. Okay? Fix ang topography, fix ang aton nga building. Okay nga sir, ang aton nga KZ is the vary. Paano mag-vary? Okay? Kaya ang aton nga principle for wind pressure
Patay ko, sir.
Beta. Ang aton nga wind pressure is the vary sa aton nga location or height sa building. Okay? So from the bottom parts ng aton nga building or sa mga ground surface, 0 ang aton nga wind pressure or KZ. Okay? So samtang kasama din, okay, ang aton nga wind pressure is the increase variation. So this is our wind pressure. So mas taas ang iyong mga building, okay, mas dako ang iya nga wind pressure sa babaw. This is the effects ng aton na KZ. Okay, or aton na velocity pressure exposure coefficient. So magina, sa aton na KZ, we have identified ang aton na types of exposure, di ba? Okay. So di ba we have identified our types of exposure. Galing, at different heights, they increase. Manotice ninyo, kung they-increase ang aton na height, ang aton na KZ is also increases. Even na inay ilang exposure. Isang exposure D, 1.08, 1.08, so on. So kung nasaka ang inyong mga building, ay mas taas ang inyong mga building, okay, mas dako iya ang wind pressure. Ang una ka, ang design for high structure, or I mean, mga high-rise structures. Na-notice, anong shape sa Burj Khalifa?
Gamo, sir.
Hindi ba ka-vary sa tamang kababaw? Kaya ang ato na wind pressure is mas dako sa babaw compared sa okay? So we can quantify this increase of wind pressure sa aton nga KZ. Okay. So anong difference sa aton nga KZ kag QH? Ano yung KZ kag QH? Kaya ang aton din siya ng QZ, di ba, we can compute this from our Q. Okay? So in order for you to solve for your QZ, so 0.613 KZ, KZP, KB, B squared. So inyong ang QH is equal to 0.613 inyong ang KH. Namingisi sa KH.
At
The equivalent ng KZ at the mean roof height. Okay, so for short, ang ato siya na C, R na C, these are the heights from ground level. Okay, so for our leeward wall, fixed na ginagamit na KZ, which is from the mean roof height. So if whatever value sa mean roof height ng nasuma ninyo, ang inyong leeward at side walls, fixed ang iya na QH. Wala siya na-vary. That's why ang atong na uniform load for our side walls are always, and itong na wind pressure sa side walls are always uniform. Okay, pagbuhat niyo siya, uniform, pagbuhat siya uniform, pagka Friday, civilian. So, where you are? Okay, same ang sa atin na leeward wall, which is QH siya. So, ang ating na value sa wind pressure din is always uniform. Uniform siya. Ay wala siya, jack shirt. Oh, wow. Off the record. Oh. Paano itong na windward wall? Na KZ ang ginagamit. Okay, we will consider the varying effects ng ating na wind pressure. Okay, sa baga, ang aton niya na windward wall, siya ang first na ma-sensitive. So possible, ang bottom part ng windward wall, wala sa wind pressure na ginakarry. But rather, ang maglabo sa inyong side wall is just the effects ng pag-flow sa hangin. Kung siya nga uniform siya, we will have 4 directions. That is our directional procedure. Kaya aton yung windward, we will consider the effects of the heights ng building. Okay? So that's why KZ siya, kaya ang atong na Z is the height from the ground. So let's say, ang building is total height na around 9 meters. 9 meters siya. Okay? 9 meters. Paano na siya? So let's say our building is under exposure beam. So 0 to 0.4, 0 to 4.5. Okay, so we can assume, no, na manitsura sa atin na wind pressure sa windward side sa wall. Manitsura. Galing, kabudlay ko i-compute no, kung parabolic ang shape. Okay, this is not parabola, but rather cubic na siya. Later on, i-discuss natin next week mo paano siya na-derive. But ang hambal ni LCP, if sugod sa 4.5 na height, okay, we can assume na this is uniform. So for short, ang atong na maximum dali is referred to kung ano ma-height. So ang atong na value sa Q is always in a reference. So this is Q at 9. Sorry. Q9. So this is the velocity wind pressure at 9 meters above the ground level. Kaya ang atong ginagamit dali ng K is at the 9 meter. Or I mean 9 meters. So, let's say dali. Iyang height is around 6 meters. So ang iyang na magnitude is defined as the Q at 6 meters. Wherein ang atong na ginagamit ng K is at 6 meters. Okay? So ginagamit lang ang KH kasi since fixed ang aton na mean roof height, depende sa aton na building. Okay? So that would be for our velocity wind pressure. So we will discuss another set of problems next week, including roof. Okay? Ano kita tayo next week?
Tuesday.
Tuesday, Friday. 3 hours naman. Okay? I did lang. 2 hours. Let's see anong pacing sa other sections. So far, kamong advanced.
Yay!
Baka siya next week.
Ay!
1 hour lang. 30 minutes lang. 30 minutes. Okay? Questions pa? Okay, ang inyong floor plans. Okay, kinala na sa bomb.
Yep.
So, same ko sa kinahatag sa previous section. Okay? Ang inyong mga floor plans, please label, no? Okay, ang may wala pa. Okay, please put labels. Okay, please put labels sa inyong floor plans, din ang inyong proposed locations ng columns, proposed locations ng bins, okay, kang inyong mga openings.